we are being asked to differentiate the following functions from first principle. Hence, find the gradient at x equal 2. So the function is 2x squared minus 5x minus 3. Alright, so let us see how this would go. Remember, when you differentiate a function from first principle, it's a matter of finding the gradient between 2 points as those points get closer and closer. So first, let me just draw an x and y axis, and let's imagine that this is the graph of the function. Well, let me redraw that. Suppose this is the graph of the function, right? Or let's put it somewhere nearer to here. Let us say you want to draw, or you want to find the gradient between these 2 points. There's x here. There is this distance. Let's call it a small change in x. Let's call it delta x. And then, well, we could call it delta x, but sometimes the delta and the x, 2 different letters, might cause a mix-up. So let's just call it d. Alright? And this x plus d. You could call it d if you want. Right? But delta and x are 2 different letters, and sometimes you see the x and you get it mixed up. The x and the delta, mix it up with the original x. Now, this is x, so this is f of x. Alright? And this is x plus d, so this is f of x plus d. Okay. Now, or should I use h? Yeah, I remember seeing somewhere, I think in some PDF file where they use h. H is a nice letter to use. So let's call it h. Alright, h is a change in the value of x. Now, what's the gradient of this graph? We're just quickly reviewing the gradient. The gradient is equal to rise, which is y2 minus y1. Let's call this point 2 and this point 1. y2 would be f of x plus h minus y1, which is here, which is f of x over x2, which is this, just x plus h minus x1, which is x. Alright, so our f of x is 2x squared minus 5x minus 3. So the gradient of this point, and by the way, we want these 2 points to get closer and closer together. So at some points we have the gradient is the limit as x approach as d approaches 0 of that equal. That will give you the exact gradient, right? Or the derivative. So here now, the derivative of this thing is going to be let me just fix this up good. You can say the change in y we could use this notation to the change in y over change in x equal, right? Instead of just g that I put here, is the limit as x approaches 0 of what now? Is going to be f of x plus h, which is 2 x plus h squared. Instead of x squared, is x plus h squared minus 5 times x plus h minus 3 minus, we have all of this, right? Minus, then 2 x squared minus 5x minus 3, right? That's the y2 minus y1, where I put in x plus h instead of x, and then the next one minus f of x, y1 would just have in x alone. y2 has in x plus h, y1 has in x, alright? Over change in x, which is x plus h minus x. So it's x plus h minus x. Oh, what did I write back? X equals 0 is h, I mean x tend to 0 is h that is tending to 0, alright? So remember here, h is tending to 0. H is a small change in x. You have x and then you go a little further, x plus h. I'm going to imagine that the 2 points get closer and closer together, right? So h tends to 0, it gets shorter and shorter. So the change in y over change in x will be the limit as h tends to 0 of. And by the way, remember later on we're going to change this to dy by dx as h tends to 0, alright? So what is this up here? Up top here, we're going to have 2 times x plus h times x plus h minus 5. Well, we could just open this bracket from now. Negative 5 times x, that's minus 5x. Negative 5 times h is minus 5h minus 3, alright? Minus. So remember, this minus is this one, right? So we'll put back the square bracket here, minus. So remember, we open this bracket inside. I have the negative 5x, negative 5h, and minus 3, right? Close the bracket. Minus, let's open this bracket to the negative 2x squared. This is going to be plus 5x plus 3, alright? So that's what you have up top here. X minus x is 0, so we have over h here. You see that? Make sure you're following, So this is equal to the limit as h tends to 0 of. So multiply out these. So we have our straight line up here, and then 2 times. So we have x squared plus hx plus hx plus h squared. You see that? So after that, minus 5x minus 5h, right? Then minus 3. We still have a square bracket, minus 2x squared minus plus 5x plus 3 over h. Then let us now simplify it even further. Is the limit as h tends to 0 of. Alright. Let's put back our line here. Up top here, let's multiply out the 2. I have 2x squared, 2, hx plus hx is 2hx. So you see this hx plus hx. 1hx plus 1hx give you 2hx. You could just write that from now. 2 times 2hx give you 4hx plus 2h squared, right? Minus 5x minus 5h minus 3. Could just remove this bracket. The square bracket minus 2x squared plus 5x plus 3 over h. You see that? Equal the limit as h tends to 0 off. Alright, so what happens here now? Let's put the x squares together. We have a 2x squared here. So 2x squared. We have a minus 2x squared here. So we put minus 2x squared. There are no other x squares. What about x's now? Numbers with x. Alright, we consider h as a number. So we could put plus 4hx, that's this, minus 5x plus 5x, no other, so with x alone. Alright, pure numbers now. 2h squared is a number, plus 2h squared, that's this, then minus 5h, minus 5h, minus 3, plus 3. So have we covered everything? 1, 2, 3, 4, 5, 6, 7, 8, 9 different things we added. Have up here add and minus. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. So we have all 9 of them. Over h. You see that? Then the limit as h tends to 0 off. Alright. Let's see what happens up top here. We have 2x squared minus 2x squared. This is gone. Negative 5x plus 5x, that's gone. Negative 3 plus 3, that's gone. Let's write down what we have. 4hx plus 2h squared minus 5h, that takes care of everything, over h. Right, it didn't need to be that long. Equal. Alright. Is the limit as h tends to 0 off. What happened here now? Let's factorize. We put h outside the bracket. We have 4x, then plus when you factorize 2h squared, you have 2h. When you take out h, minus 5h here, we're going to have 5 over h. H will cancel h. Alright? H cancels h. Now, as this happens, the change in y over change in x is going to be the limit as h tends to 0 of 4x plus 2h minus 5 That's all we have because h cancels. Equal. Now, as h tends to 0, 2 times 0 is 0. So what you have? Since we have this happening, when we check as it tends to 0, then we call it dy by dx is equal to 4x minus 5. 4x minus 5. That's what we have. Let's see something here. Suppose we had differentiated this directly. So it would be 4x minus 5. Right, so it is correct. 4x minus 5 is indeed the derivative. We did it from first principles. Now, at x equal to what is the gradient? So, at x equals to dy by dx would be equal to 4 times 2 minus 5, which is 8 minus 5, which is 3. So the gradient would be 3.